Hey, let's begin. And just like the last couple of weeks, we're going to continue with the water solver. And yesterday we let's see here, we added an algorithm for calculating local minima based on some based on some arguments, and a local minima is a point in the terrain which has a height that is less than all of its neighbors, and at least one of its neighbors has a height that is bigger. So given a max step size, we can also find a minima. Let's see if it works here. Yeah, so if we add water to this point, we find the closest minima, which is here, and that's where we actually add water. I think we can do the same here. Then we get this one. And the way we calculate closest might be a bit weird, because we always move, like the algorithm always tries to move in the direction with the most decline in height. So yeah, and what we're gonna do today is we're gonna extend this one, or we're gonna add an alternative to it. So instead of finding the first minima, we're gonna find all minimas. And yeah, because I'm still thinking about, even though this one yields kinda good results, especially when you use local minima as a like we calculate local minima first and then start at that point. But there still exists some cases where this one doesn't yield a good result, so I'm still having high hopes for this implementation. In Mana Pro, you're doing terrain again. Now we're actually doing water, or terraforming with water. So the idea is that we will be able to add water like this, and the fluid solver will calculate a stable state. This one might be a bit rough, but actually I'm not. Yeah, we could do some nice things with this. So yeah, we want the algorithm to calculate a stable state, and then we're going to generate some meshes from that and apply some cool water material. So the player will be able to create lakes and rivers and even waterfalls. Best case scenario. So what's up, Sommerfeld? What is the biggest challenge while developing a creature collecting game? That's a good question. Probably right now, I think for me personally will be creating the 3D assets. Programming wise, I think this terraforming is the toughest challenge, but we're handling it pretty good. Yeah, so we can see here that we get some uneven points, and that's okay. But a worst case scenario for this algorithm that I've seen would be something like, I wonder if it's here maybe. Yeah, so we add a pool of water here, and we get something like this. And honestly, maybe it's not too bad. So it's pretty much like we have a big pool of water here. We have water flowing down on the sides like this at all times. So you will have a broad river like this. It's not too bad. But hopefully the minima to minima algorithm will fix or will clean this up a bit. Sommerfeld, it looks pretty good already. Thank you, I appreciate it. Yeah, we're gonna add some more variations to this terrain, so we have some more test cases. What's up, Cooler SK? Yeah, we're turning this grass planet into a water world, indeed. Although I think we should... Okay, I might crash Unity now, but if I add water here... yeah, we actually add it here. So we have fixed the issue with adding water on a plain field. If we don't find a minima, in a set amount of steps, we don't fill it. That's pretty much the current solution. Good morning, Geralt. And the selection of local minima is maybe not the best. I wonder. One sec, I'm just gonna see a thing here. So let's go and remove all of these. So when it comes to local minimas, for instance, if we add water, let's see, test. If we add water here, we get a local minima here. I'm starting to think it should be okay. Yeah, I definitely want... Yeah, we're gonna do it like this. We're gonna find all local minimas and we're gonna draw... We're going to print all of those. So our current algorithm for finding minimas is here, get terrain point minima. We're going to rename this one to get closest. And then we're going to add public. Or if we want it as an array, get all terrain point minimas. So this one is going to take way longer. We're pretty much going to do max distance in every direction, and max distance is a float value, so we check it here. So when we jump to neighbors of a point, we check if the neighbor is within max distance. It's probably gonna look exactly like this, except we will not early return, which makes me wonder if we can just merge them in some nice way. basically everything we need to do is we're gonna have a list of minimas here, and if we want all, we're gonna return, or we're gonna add to the list here instead of returning, and then we just return the list here. But yeah, here we want to return 1. And we probably don't need to sort it either, I don't think. Yeah, let's just copy this for now and change it. Definitely want a start point. We want visited nodes, we want possible minimas, and we want minimas. And here we do minimas dot add possible minima. To do fix. Yeah. Already possible minima already visited, and then I want to add bool already minima. So already possible minima and not already minima and not already visited and within distance, if so add neighbor. And then we don't need to sort it. We want to find all minimas. So we can do this. Although I wonder if we want to do return minimas dot order Yeah, it all depends on what we want to order them by. I think we just want to order them by height. No. We want to order them by vector 3 dot distance between start point dot position world space and minima position world space. So the one that is closest to the initial point, we put that one first in the list, and then we just order them. Okay, so closest to furthest away, and to array. I want to try this one. Might get... Yeah, it's gonna take some time. Hopefully it will never crash. And then we can do fluid solver mode, and we're gonna do naive recursive CPU with first minima. We're just gonna do, so the test is going to be terrain point, all minimas. What's up, Paleson? YouTube has never featured a live stream on my feed before. The fact that this happened with a small channel makes it even more remarkable. Thank you, YouTube, and welcome. So we get all minimas, and then I want to do for each terrain point minima. So basically what we're gonna do is we find all minimas and then we just spawn a fluid visualization object. Paleson is funny since I do not watch anything related to coding. Yeah. And then I wonder what happened. It's actually Swedish. South of Sweden though, so pretty close to Germany. Get all minimas, for each minima spawn a fluid visualization object. Let's see if it works or if it will crash. You have the exact same accent as a German friend I have. Well, I usually hear I have a Swedish accent. So hearing that I have a German accent is quite interesting. And I will take it. I will take it. Okay, let's see here now. So there's a slight risk that my editor will crash. Worst case scenario, my stream will crash, but I'm just gonna try this. So let's add some water here, and we're currently in fluid solver mode test. So we're just gonna add minimas, and I wanna add it here. There we go. Yes, okay, I think this is good. This result, we get minima here, here and here. We don't go all the way down to here. Although I see here when we calculate minimas, when we try and get minimas, we want to take the fluid amount into account because we don't want to walk from here to here if we don't have enough fluid for it, so to speak. This is good. We're gonna try it again, and I want to try it. Oops. I want to try it over here, I think. And we can see that it takes some time, but that's okay. We're gonna offload it to a second thread, and this is beautiful. Here we get these 4 minimas, we get this one. I want to this is great. Although I wonder, yeah, we want to avoid neighbors like this. I want to see what happens here as well. Oh, this is beautiful. So the idea is that here we create a, or we fill this area out with data based on these points, and we fill this area out based on data of this point, but we also want to walk from this one to here. So I wonder, I think we want to remove duplicates first of all. We don't want all of these. And I think we can do that pretty easily. We just need to check if they are neighbors. Yeah, I think we can do that pretty easily. Like when we get to these points, they are all local minimas, but I would say, yeah, we probably want the one with the lowest. They will have the same height pretty much as well. So yeah, I think we can just take I wonder if we can remove duplicates in a nice way. A little bit skeptical about these two. Very skeptical of those two. Luth Coder, thank you for the follow, appreciate it. Are these actually a minima? Yeah, okay, so I'm still worried about those two. Love the character design. Thank you, appreciate it. I would love to be able to print the heights here. Yeah, maybe we should do that. So if we would do this, do I want to print? Yeah, I think the error might be, let's see here, what did we do? Minima error margin. Yeah, this one might give us more minimas than we want. Minima error margin 0.001. Okay, let's go 0.00. Add an extra 0 there. Still get those. Yeah, let's do this. We're gonna jump to Terraform, or actually Action Terraform. And I wanna add, do I have an object like this? Let's do prefabs, user interface button map. Yeah, I want to add a let's add a 3D object, or let's see, is it UI? Text, there we go. And I want to add a material to this one. Button map, do we have? Resources. Yeah, let's try this one. Oh, beautiful. Although yeah, we might want to add it here. Okay, I get it. Let's just use this material. Actually, I thought we had button map. What's up, Namida? I think it's pretty good. Okay, so this text and this one, we don't have... They should be using the same... Okay, they use the same material, great. So I want to do... What size do we have of this one? Font size 8. TMP, let's see, font size 8, is that too small? Yeah, we have a smaller scale as well. And we want to do... auto size. Would love to make this object only as big as the text. What are we gonna have? We're gonna have 0.1, something like that. Do we actually set it from code? Maybe we do. Let's fix it. User interface, what do we have? Buttons, information provider, information displayer. Yeah, I think we're gonna do... think we can probably run with this one actually. And here we get the materials, beautiful. Yeah, we should be able to run with this one. Main camera. Yeah, definitely. So let's remove text displayer. And let's do, so I think we should be able to do information displayer. We need information provider. Get information. Going to be a little bit dirty from the start, but I'm okay with that. Action terraform, we're gonna do brush, debug settings. Private, what was the name? Information displayer. And then we do awake and is it actually this one we want to use? Probably. So I want to do visual information. We're gonna name this one height. And then we're gonna do create name string. We have a lot of default values for these. create with default visuals. That's what we want to do. Name and text. Create with default visuals, and we're gonna name it. Oh, actually, that's not here. Here. Create with default visuals. We want to have a name, and we're just going to do type dot get description. We're going to leave the text empty for now. Then every time we update the Terraform point, update the bug marker, height visual information dot set post, update the transform, great. Update transform Terraform brush dot brush position, but we might want to add some offset here actually. Do we have that here? We can do, let's just do 0.5 up. But we also want to update the text. Actually, if we use this one, we don't need to do this. Which is good. Yeah, this one is going to be a little bit more tricky. We pretty much need to get the terrain patch. And then get the height. Or I think we can do this. Vector 3. Then we do this, but I also want to do terrain patch. Yeah, let's take a look. origin direction. Origin direction should be down, and max distance, I don't know, 100. What more do we have? Layer mask. No, we don't want to use that one right now. But we want to do out raycast hit. But do we need... Yeah, raycast hit. Yeah, and of course we need to put this one into if we hit something, that's when we want to do height information update to transform. If we don't hit anything, we're gonna do some more things in here, but if we don't hit anything, dot, do we have hide? Yes. And here we're gonna do if, we're gonna do terrain patch hit patch is equal to and then we do if hit patch is not equal to null. That's when we're gonna do stuff. And what I want to get is do we have anything hit patch dot we can get indices, or we can get position in world space using indices. What we want to do is we want to convert. Yes, we want to jump to Terraform data. Can we do this? I think we can use this one. Circle origin, circle radius. It's a little bit of a mess. Circle origin divided by step. think we're gonna have to implement terrain patch. Yeah, we need to get origin. Yeah, okay. Generate Terraform data. We're gonna do so given a world space position, we want to do this. And this, and then we have an offset. And then we pretty much want to do this. Position in object space with offset. I think that's how we're gonna do it. And then we do this one plus this one. And then when we calculate center, we do this and delta. But here, instead of creating a new like this, what we want to do is, I think we want to return this one. Yes, we just want to do return get vertex. This is our X and this is our Y. Ooh, I think this is what we want to do. Baseball Bandit, what's up? Any recommendations to learn code at a young age, like a website? Just do it. That's my recommendation. When it comes to website stuff, I don't have any good resources because I don't really do a lot of website deving. I think this is what we want to do. Action Terraform. So what we can do here is I think we're just going to do float visual height is equal to hit patch dot get vertex closest to world space position, and it's height, visual information, position. Is that it? Yeah, and then .y. And then we update the transform, and then we do height, visual information, set text. Yeah, it's not pretty, but hopefully we'll get some visual information now. We should have what? Terraform height visual information, there we go. But we don't show it. We do change to, oh yeah. I want to show it. Ooh, that is rough. Not really sure what's going on there. There we go. One. Not too sure about that one. Yeah, I think it's good. Maybe we could even add some more information to it. So right now we just show 1, and here we get some values. So what I want to check is, let's go water, let's add. Okay, so we get a local minima here. What do we have? 0.0039. Yeah, that makes sense. This one. It makes sense. I wonder this one though. 3764. Is this point actually higher than this one? That's... yeah, it is. I'm having a hard time seeing it, but it looks like it. Yeah, I think we're gonna clean this up a bit. We're gonna get some more information out of this one. Definitely. Nicodit, thank you for the follow, appreciate it. Yeah, that's good. Yeah, we might want to make the it's not too bad. The readability, maybe we want to change. It is a bit small. And the code for getting the information is a little bit of a mess. So let's do... What do we have here? We have a size of 0.5, 1. And maybe that's better. Although I'm not... Yeah, I think I want to use, let's see here. This is good for now, but I want to add some more information to it, definitely. And clean this up. We're going to use this a lot. So update Terraform point. Yeah, I think we might as well just do terrain. Show information for point. might want to move this to the Terraform brush as well, but we'll see. Point. Just do point. Let's see. We want to raycast down, and we want to do that in here. But when we get a hit patch, yeah, we want to do this. Then we have visual height. Yeah, what I think we're going to do here is terrain patch. Position, world space. And here we do get vertex closest. No, we're gonna do get index closest to world space position and to position world space. Fuck this, we want to do int, and then we want to return index here. Okay, although I wonder, maybe I jumped the gun a bit. I think we did. Or I did. Let's see, we want to go back. To here. Okay, now we can do some cool things. Let's also do terrain data container. I think I want to define some constant strings here. Probably want to wait with that, but we want to do return height Yeah, I think we want to go with raw height. What is it? System, new line, something. Environment, new line. Yeah, we want to do system.environment .new line. Dot raw fluid mount. Action terraform, and here I want to do, I don't care about the set text. Oops. So I'm thinking of doing, we're going to rewrite this one a little bit. We're going to do this, and then if this one does not hit anything, then we just do no, actually, let's keep it like this, but we want to change this one to string information is equal to hit patch dot get information point, and then we do update transform set text and show if information No, we will always have information here. So we do this, but then we remove this and this. And we do height visualization information hide. And here we just return. So get hit patch, get information from patch, show it. If this one fails or this one fails, we will just flow through to this one and we hide it. Why? Yeah, do we want to change the size of it? Nah, this is okay. And if we do grass value. Oh, that's beautiful. And if we do yeah, this is going to be useful. Actually, do we want to do... Ooh. I wonder if I implemented this one. Ooh. Yeah, we could probably implement it the same way we implemented this one. Although... i.e. being able to show it and hide it. Fuck, that would be clean. Yes, it would. But it depends on a few things. Let's see. Action, information. Action, interaction, inspect. So interactable inspect. Here we have information providers, and then we have get information. Although we don't have any position, which sucks. But information provider, no. I think, let's take a look here. Inspect, it depends on in-state processing, so it depends on interaction interaction focus. Like, we could probably make this work pretty easily, but good morning, Desai. But it wouldn't be clean. Like, we could probably get input handler, this is like, if we could make it work with action, interaction, inspect, it would be so nice, because in the future we're probably going to be able to inspect the ground, but we will not leave. We will not provide the same information. So now during debugging we want to show grass and height values, but in game we will probably just show what it is, like if it's grass or yeah. The entire problem stems from the fact that we need a position. We need world space position, so focus point in world space. And I don't think we have that one here. Focus, although I want to see playable entity. Add listener focus. We just do it like that. So we could do we get a game object, we check if it's an entity. And this builds on the fact that we need to define the ground as an entity. I'm probably okay with that. Yeah, I am. But we still need a position. What do we have? Action, interaction, focus. We have an entity provider. Yeah, I think we're gonna do this. Don't we have... Is it in action? Action dependency. Action type, dependency type. State. Provider interrupts processing. Yeah, I think I want to do this. Let's see. Yeah, I do. But action reference, I wonder. Yeah, I think we want to go to action. What do we have here? Dependencies, type, state. I want to introduce action point here. Point of interest, that would be interactable. Good morning, GK. Like it's just a question of, is this something I introduce just because, like, is it only going to be used for this? That's the big question. I don't think so. If we take a look at, yeah, if we look at action terraform, we're definitely going to use it. Action jump, probably not. Collect and pick up. Yeah, I think we're gonna use it. Let's see here, action. Although I think so. But I want to implement it as public virtual vector 3. I want to use not point, let's go with point for now, and it's just going to be position by default. It's more going to be like a coupling point, if that makes sense. But anyway, here we want to do description. Yeah, so if we do inspect. Handle interaction. Visual information show. Yeah, this is. And then we have offset here. I wonder. We're gonna handle this one. Yeah, we're gonna use this for animations later on here as well. Let's do 3 point. We might as well. Label entity, add listener. Wonder if we can do. Invoke hit game object, point position value. Would love to use null conditionals here. Actually, what do we get if otherwise false? But what is hit info if we don't hit anything? I wonder if we can do point focus event. Very interested in if we can get this to work. And then it would look something like action terraform. We're gonna disable this one for now. And let's see here. So what we get now is we have an action interaction focus, we have action interaction inspect. We're gonna assume the terrain patch is an entity right now. So we get handle interaction. This, we have a point here, so let's jump to inspect, handle interaction. Then we have visual information show. So if we're in processing, we do this, visual information, or actually information providers. Yeah, what we're gonna do is we're gonna do this. Get information. Okay, so in terrain patch we add I information provider. And in this one I also want to include Radicat, I don't know. I wonder if I want to add a string get information with a vector 3 point here. But we're gonna get a lot of that hasn't implemented this one. Could you do I don't think we can do but what we could do is, let's see here. Now that's pretty good. Yeah, this is pretty damn good, I would say. Attribute handler, however. Slayer JSS, thank you so much for the follow. Appreciate it. It's not too bad. Get information. my question is, can we do interactable inspect? Let's just do this. It feels a little bit wrong doing this, but we will probably use this eventually in these as well. But yeah, I don't know. Let's see. Get information, and here we want to do interactable inspect. Actually, yeah, we want to do this because we want to update it every frame. That's true. Yeah, and I just thought about an additional problem we might have with this. Yeah, we will just start the processing once. Yeah, what we're gonna do is, I think, action interaction. Yo, what's up, Fabik? I'm doing good. How about you? Have you gotten your sleep yet? The sleep you need? And we have... oh, nice to hear. We have diverted a little bit today because I came to the conclusion that we want to be able to focus the terrain, but initially we implemented it in a standalone way, but I want to implement it with the action interaction focus system we have in place. We pretty much we want to show information for the terrain at specific positions, like what height we have and stuff like that. We're not going to show that in game, but when we have it in game, instead we're going to show what is actually appearing on that position in the terrain, I think. Yeah, systems are evolving indeed. But I think we're gonna do this. So pretty much most action interactions will have a process later on, I think, because we're gonna, so if we consume something, we're gonna start a process that is going on until cancelled or the object itself is fully consumed. So in action interaction, or actually in action, we probably want a numerator. But for now, okay, so I'm thinking of doing if state processing. Ooh, this one is rough. Yeah, this is what we want to. Yeah, this is an ugly implementation. Let's see. Let's do public IEnumerable inspect routine. And while action state is processing, or processing just. Or actually, yeah, while state is equal to action state processing. Then we want to inspect this one, and we want to do it with information. We want to fix this one. Or do we? And we want to do string join, new line. Information provider select I, and for each one we just want to send in the point here. And then we want to return this one, so we might as well do this and this. We don't want to do late update, instead we want to do visual information. We want to move this one down to here. Inspect routine. Yield return. Whoa, 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 whoa. Get information, and here we do vector3 point is equal to let's see. Actually, never mind. We want to have point here. We want to send in point here. The question is what we get from where we get point from. We're gonna send it in here. So we're gonna inspect things differently depending on inspection point, pretty much. So when we handle interaction, when we start processing, we want to call visual information show. We can do this one here. We can do this one here. So right now so basically what we want to do is handle interaction. This one is going to change. Ooh, that is true. Fuck, what a mess this is. Yeah. If we go to action inspect, start processing, what I'm worried about is the fact when we change point of interest. Like, I would probably like to do something like this, although maybe it could probably help later on, but I don't know. Interactor dot point inspect. We want to do if no, that's not what we want to do. We want to let it run its course. Stop coroutines, and then we do inspect coroutine. Inspect interactor. And I think this is also good. Now for each interactable inspectable, we want to do this check each frame. So handle interaction. This, like, logic like this, coroutine logic, is probably going to be moved to interactable down the road. Generalize and move to interactable. But let's see what happens now. So if we have action, interaction, inspect, this is also general enough that we don't need to put it here. So handle interaction. We can generalize this one as well. So we start processing. If we have an inspect coroutine already, we stop it. And then we start a new one with this new interactor. And what we do here is, while this one is still processing, we show the information. I want to see if this still works with the previous implementation of inspect. What's up, Smack? It's going pretty good. Yeah, we have this one left. Information display late update. And one more thing. Yeah, set text update transform. This one, we also need to fix this one. But here I think we can do damn, I think this will be much better. Much better. But the big question then is this one. Get information. Information displayer. Do we even use this one? Yes, okay. Okay, let's see. So if we show info here, we get the information here. Yeah, that's not really what we want. But we can still show information, that's good. Oh, and it works like this as well, good. What I want to do is... I do wonder why we get the information there, however. Inspect. We send in interactor, we do interactor point. Yeah, that explains it. Action interaction. The point we get here is... yeah, the point we currently get is equal to transform.position. So just like action interaction focus, we do point is equal to or we return focus point when we ask for point here. We want to do something similar with inspect, but we want to do it with dependency. So it's gonna look like action type point. Entity provider. Yeah, what I want to do here is we're gonna do hell yeah, we want to do action interaction inspect, and here we want to do entity provider. If it's equal to null, or actually point otherwise. So interactor inspect depends on interactor focus, and if we want to do an inspect, we get the point from what it depends on. Yeah, beautiful. So we can see we have an offset. I wonder if I'm okay with that one. Yeah, we want to fix that offset for this one. Thank you, Fabric. Yeah, I think this looks nice. And now now we want to do the same with the terrain, but that one is going to work a little bit differently. Show info. Yeah, we want to adjust these offsets definitely. Don't we have anything for the bed frame? No, we don't. Yes, let's see here. We can be a bit more lenient on the do we do it like, let's see here, character. Okay, I think that's nice. I think we do that here. Let's see. Every interactable is focusable. My question, yeah, inspect, and then we have set, offset, bounce, size. Yeah, we don't need it to be this big anymore. We want to offset it a tiny bit upwards, but I think a 0.1 F is just enough. But I'm gonna fix some additional things. So one thing as well, so let's see here. When we do, so entity, we have on destroy. Playable entity. Okay, so when we focus an object, we do add listener action focus. Is it actually in animate entity? I'm just trying to figure out, one sec. Because when we work with extremely big objects and we focus them, we want to show, right now we show the possible interaction at the focus object. Like this one, we show sit, show in for here. But when we do it for an object that is extremely big, like the terrain, we want to show it around the actual pointer. Where exactly do we do that? Action focus. Yeah, we bind actions here. Show affected game object. Okay. I'm not entirely sure I want to change this too much because we probably... Yeah, right now we have the actions appearing at the object in question. I think maybe we want to do that later on as well. Get affected game object. Why are we working with game objects here? Get affected game object. Okay, I'm gonna have to think about this one a little bit more, but... Or can we just do... Like, if I highlight this stool here, we can see that the actions available to it appear at the position of the stool. If I highlight the ground here, we want the actions to appear at the point and not at the position of the terrain. And we make it appear at the correct position thanks to get affected game object. Fuck, I think we can do get affected game object. I think we can do this. Affected game object, we get the affected game object like this. We still want to do that. Can we just do bound action? Owner. Do we need private? We just do it for... I want to look at it. Or we want this one to look at the camera, that's true. Yeah, and if the owner moves as well. If owner... use it here, and we use it. I think we can change it to this without any big problems. Yeah, we have this problem though. But that only holds true for our... Yeah, I think we're gonna do it like this instead. Let's see here. Bound action. Yeah, update button information, bound actions, first or default. If we don't have a bound action, yeah. I'd appreciate it, Fabik. Enjoy that breakfast. Okay, this is beautiful. Okay, that's great. Okay, so the next step is to do this on the ground as well. And for that to work with our current implementation, then we have to do, let's see here, entity. All of these we don't need in this one actually. It's going to be an animate entity. An entity is static. So yeah, we won't need this one here either. Nor this one, but we do need this one. Fuck, how come I have these things here? Ah, that's weird. Possible, yeah. Move dynamic or oh wow. Yeah, it's going to be possible to clean up it's gonna be nice. I think we will be able to clean up Action Terraform pretty nice as well. Yeah, definitely. Attribute handler here, I don't think we need that one. But let's see, what do we do here? We add a rigid body. That we get a rigid body. Focus, inspect, pick up. That's not true. Yeah, okay, the current implementation of entity sucks. I wonder if, yeah, we might do this now. We're gonna introduce We're gonna have entity, then we're gonna have dynamic entity, then we're gonna have animate entity, and then we're gonna have playable entity. Just different levels of how something moves in the world. Entity should be static, shouldn't have any rigid bodies or anything like that. Yeah. So I just want to check. Implement entities. That's not very descriptive. Implement entities. Implement the following. Entity. An entity that can I don't really know how exactly to define these in a nice way, but an entity that can change, transform. This is basically what it's going to get down to. An entity that can change, transform by outer influence. Also change, transform from its own influence or by its own influence. Entity that can also change its transform based on player input. Static entity, dynamic entity cannot move by its own force. So, for instance, consumables, items and such, animate entity, creatures, non-playable characters, and unplayable entity. And the further way we go down, like in an animate entity can also change, transform from out of influence, and a playable entity can also change its own. For instance, if ragdolling, or if it gets knocked away from an animate entity. Yeah, so that's what we're gonna do. And that is because, like static entities, we still want to be able to focus them and interact with them, but they will never change their transform based on those interactions. But that is a truth with some modification, because, for instance, the terrain will be a static entity. And yeah, its transform won't change, but its vertices making up the terrain will change. Yeah, so that's what we're gonna do. But before I continue with that, I need to run AFK real quick, grab something to eat. So be right back, a couple of minutes. Okay, back. Let's see what we can do about this. So I want to introduce... dynamic entity. Yeah, we're gonna do that one now, but let's see here. Attribute handler and no, a static entity will not have an attribute handler. That's for stuff like age and yeah. So we're gonna move these two to dynamic entity. Interactable all yeah, interactables. A static entity can have interactables, but yeah, because we might want to climb it and stuff like that. Marked for destruction. What do we use for this one? Yeah, we're gonna leave this one. Destroy event. Why do we use... Oh yeah. Although I wonder... we can leave with that one. Or leave that one there for now. Yeah, bounds, still want that one. I'm gonna leave them as those as they are. We want to move both of these. We want to get colliders here. We want to add a focus here as well. We want to add an inspect here as well. Pickup we don't want to add to this one. Save current transform. We're gonna move this one. For each interactable, add to that one on destroy, on application quit. This one I'm a little bit we're gonna do this. Enable physics. We're gonna leave rigid body. We're gonna change this one to public virtual. We're gonna leave this one, but we're gonna move this one. Welcome back, Fabric. Unfortunately, no. But we're getting there. Align with transform. Yeah, we actually want to be able to This one we want. Yeah, reset. This one is a little bit of a mess. Something like this. Oh yeah, that one sucks. Do I need to do require component type of entity? A little bit worried about entity and dynamic entity. Can we do... Does it work with... Yeah, so if we do... Let's see if it works. One which... Okay, it does not. This is a mess. Wonder if we can do... Let's worry about that after, but I think we can do, what do we have here? Entity. Yeah, let's just fix these and continue. Okay, so it works from now on, but is that it? Let's see if it works. Not really. What do we have? Interactable pickup, but we don't get inspect focus. Almost indeed. Why don't we have the option to pick them up? Oh, we actually do, but we have them over here. Okay, the problem we're having is apparel handler, headwear. I'm gonna remove this one and move up. But it's not missing. Okay, what more do we have? Pants. Okay, that's better. Although show information is over here, pickup is over here. That sucks. Okay, I think we want to do this. Let's see here. One sec. I want to fix the sweater The collider here is quite a little bit too big, I would say. But then I also want to do interactable, no, action interaction, and we're gonna do entity provider. Yeah, I think we're gonna do this. Interaction, focus, no, rather interaction, inspect. This one here, I'm just gonna put this one in action interaction. Beautiful. Yeah, if we don't have any attributes, we might want to skip that as well. Mattress simple. Do we have 2 attribute handlers on that one? Yeah, here we do. Actually, okay, so what I want to do is, yeah, we're gonna do attribute handler, get information for each, and we do attributes if we hard code it for now. But that's not entirely true, I guess. Looks a little bit weird here, but fuck it. Okay, so now I want to be able to put the marker on the terrain and get the option to inspect. And we're gonna do it like, I think the only thing we need to do is terrain patch I information provider. Let's see, interactable inspect, get all that is, yes. I information provider. So I think everything we need to do is get the information vector 3 point, terrain patch, get information vector 3. Let's just rename it to point. And then I think terrain base, I wonder, we create a new here, then we set layer, material, we generate terrain data. It should be okay by doing create new, we instantiate it, and then we do terrain patch dot add add a component entity. And I think that should be it. Now we have show info here. Okay, that's good. The last information though, 000. The fuck is that? Okay, we're getting information from something else. Get information point. What could it be? Oh. Entity. Get information. Game object name. That's the name of it. But we want the name to appear first. Is there a reason for... We could add priority. Yeah, it's this one. Colliders. We don't have this one until... It's probably a good idea to do... But... how many places do we need to? Not too bad. Can we solve this in a cleaner way than just including a lot of hard-coded values in each class?
Beautiful.
I don't like this one bit. But will it be useful the final UI is built. Probably will be.
Beautiful.
But we're gonna base it on different stuff then. Get information will probably return an object, an information object with image references and stuff like that. But for now this is good, I think. No, that's true. Yeah, we can work with that later. Okay, that's nice. Yeah, I like it, I like it. But I want to do one last thing before we finally continue with the water. And I wanted to the hard-coded name here. No, I want to hard-code the name. Terrain patch. There we go. We could probably add let's see here, terrain patch. We're gonna add some more information here as well. Get information. Position. Index. Index, I just want to do... Oh, we can do like this. Something like that. Should have had something like this a long time ago, I think. Okay, let's see here. So what do we have right now? Water 0.1. Terraform. In fact, do I want to put... Yeah, we do. I think we want to put... Fuck, do I want to do that now? So Terraform currently relies on Action Terraform, and that one is extremely specific. Or what I'm getting at is the Terraform action is just an action currently. I'm thinking if it should be converted to an interaction, because that's basically what it is, right? In the current state, that would involve an ugly cast, I think, but that's about it. I think we can keep it like this for now. Nah, let's worry about that next week. We're gonna return to the water, and right now we just find all the local minimas within step distance X, and it looks like this, and we don't have fluid amount or anything like that as a cost, which means that we get, if we add fluid here, like we just walk in this distance independent of height, and we also get a lot of local minimas here. So what was the first step? Yeah, I'm pretty sure we don't want multiple minimas like this. So we need some way to be able to filter those away. And like if we get a local minima like this, if there's more than one, choose one at random. Yeah, I think like the idea is that we want to, yeah, the closest one we already have. We have an algorithm for that one. But now I want to find all the local minimas that the water can reach, basically. And we want to create a path between them. And it's pretty much going to be, it's going to be the closest one, I would guess. Or like it's just like if we add water here, we want to get this minima and we want to get this minima, but we just want to get one of these points here. So there's a few different approaches we can take to that. I just wonder. Can check if the selected minima has already a minima chosen as a neighbor. Yeah, that's one approach we can take. Definitely. Okay, this is... Do you mark the minima on the texture? No, we don't. We have something called terrain points right now. It's pretty much just a very small class that holds some information about the terrain point. Like what terrain patch it is, what index it has, and that's about it. But I'm thinking about... Like, I think we have to be careful, like, when we get a couple of minimas that are neighbors, it's pretty much a list of points. When we get a couple of minimas that are neighbors, we want to pick the minima with the most fluid amount in it at that point. Because basically what we're gonna do later on is we add fluid here, we walk the fluid along and find all minimas. So for every minima we get to, we're gonna have a fluid amount, and later on when we have removed the neighbors, we're gonna have a set of minimas, and we want to take those and fill up the water at those points along the path we have walked, I think. So you can easily check if a list contains this selected minima. Yeah, so here for instance, yeah, like that would be the most straightforward way, I think. And it's probably something like that we will do. But here for instance, let's see. Yeah, I'm just thinking about I guess we could probably just do and you can check the offset depending on the terrain normals. Yeah, I don't think we need to be that specific. Oh, that is true. That is true, though. But let's see here. I'm thinking, like, there might be a way to solve this duplication error while we find the minimas instead. And I wonder... like, if we're gonna walk through this terrain with a stream of fluid as far as we can, we might be able to discard similar minimas earlier in the process, but I don't know. I mean, we could probably do something like terrain point. Here, for instance, here we check that a point is a minima. Like when we get the neighbors here, we can probably set the information for the neighbor. Yeah, we can. Like we can probably set a flag here. So when we get neighbors here, we can set that this one can't possibly be a minima because it already has a neighbor that is a minima, and that flag is only unset until or when we move in a direction that is downwards, basically. Or upwards. Yeah, when we move in a direction that is not the same height. So but then again, yeah, that's one approach. Or we can do what you suggest, Fabic. I think there's multiple ways we can do this. But before we try and remove minimas, I think we're gonna introduce fluid amount to this get all terrain point minimas, and we're gonna walk. So we're gonna decrease that fluid for each. But I'm wondering, so this so basically what we want to do is we want to, for every point connected to the initial point, we want to calculate the fluid amount in that point, and then we want to find all minimas. And we want to remove the duplicates, thinking if these different approaches would lead to a different result. Let me just bring up let's draw a bit. What I'm afraid of is let's say that this is our initial point. And we have a local minima here, and we have a local minima here. When we walk through this path, we walk this and we find this minima, and then we walk onwards and we find this minima. So if we combined fluid and minima finding, then this is the path we will get. But what if it turns out, or could it turn out, that given the properties of our fluid traverse variables, that the quickest path with the most fluid is this one, but for this one it's actually this one. So I'm wondering, like, if we first want to find all minimas, then from this point we walk to all minimas, and we find the path to that minima with the most which leaves us with the most fluid at the minima. But will that leave us with a scenario pretty much the idea is that we walk in all directions at all times, try and calculate minimas for each path. Do we want to redo this recursive as well? I think we do. I'm wondering if it would be better to find all minimas first, and then find the cheapest path from the start to each minima. And then walk along that path and fill up the water. That's probably it. But yeah, that would most definitely be possible, but maybe we should just make it work, then simplify it, because my question is if we can combine it. And yeah, so if we find all minimas first, and then we find the cheapest path to one of these, so from here we find the cheapest path to one of these, and if we find it to this one first of all, then we check if any of its neighbors are minimas. If so, we remove those, and if any of those neighbors are minimas, we remove those, and on it goes. So then we remove all the duplicates, and we also find the cheapest path, or the path that leaves us with the most water. But then again, I think the best approach is just to, we start walking here. For each step we have a water amount here. For each step we leave that water amount here, and it decreases based on the cost. So we do that with every index. If we get to a point that has less water amount, then we add that new water amount and start walking from that. Maybe. And in the end we're gonna have some that are marked as minima. And some that are not. But I also wonder how it will look maybe it's okay. Fuck it, let's do it. So it's basically, let's see how close. It's basically let's see here. Liz Gloart, thank you so much for the follow, appreciate it. like getting local minimas and filling them up based on how much fluid we have left when we get to those points. It's pretty straightforward, but the thing is, if we do only that, it won't leave us with a nice... Like that would give us... Let's see here. That would give us a set of pools with water, but no connection. So what we could do is we could mix the CPU fluid solver, the naive one, with the local minimas one, and yeah, see what we get. And then we just have to figure out the connections between them. Do I want to implement this? Yeah, I'm wondering if we might just try and implement it. So basically, find all minimas, calculate the path from the initial influx of water to each minima, and we want to calculate the path that leaves us with the most amount of water when we arrive at those minimas. So we fill those minimas up, and So the next question is, what do we... Maybe. Yeah, and when it comes to neighbors, we don't really care. We don't really care about which neighbor we take, or do we? I think we do. The hardest part about this is the fact that I want to know the path we walked from this one to this one, and so on. It should be easy. What I'm thinking is, if we start walking along a path and we always chose the direction that leaves us with the most water, like Yeah, we just do a traverse algorithm. We implement it. We always select the direction that leaves us with, that costs the least amount of water to reach our minimum point. Like, will that lead to the path that costs the least? No. Yeah, we've been... That's... Oops. Yeah, up. Yeah, that's what we're gonna do. Yeah, but we're gonna have to alter it a little bit. This is perfect. If we want to figure out, like, if we want to get all points that the water can reach, and we want to figure out the most amount of water for each point, that would be perfect. This would be spot on. But actually, yeah. Let's see here. Yeah, you're spot on, Fabic. I think we can use this one. But. Can we... The problem might be how big will the influence grid be, yes. No, these are great hints. These are great hints, definitely. We do something very similar, or have done something very similar. But what I'm wondering is now what I think. So yes, I think we're gonna do... I wonder if we can do this. We add water to the initial point, right? And then we calculate the max amount of water that each point can have. Like given our initial point. So we just spread in every direction, get every point that can be affected by the initial influx of water. Based on some costs. And all of those points are our grid, our final grid. Yes. And so then we have all of our points we want to include in this algorithm. And when we have all of those points, we find all of the minima points within those. And when we have all minima points, we calculate the minimum distance from the start to each minima. And when we have all those paths, then we start filling out the terrain based on that. I think like our naive implementation is basically this one. Simplified. Yeah. I'm just trying to see how we can convert this to our underlying data structure. Yes, that's true, Fabric. Both the terrain height and the water is texture. Yes, height is in red and water is in blue. What worries me here, though... maybe not. We don't really have a problem. I'm just trying to convert it. Like, okay, first of all, we have to select the weight of the graph. And I'm thinking... yeah, the weights are probably going to be the gradient, so like the height difference. But then we have to select... there's a lot of decisions to be made. Base it on about water added. So if we base the weight of water added, doesn't that mean that we have dynamic weights? Don't you want these weights to be static, right? Like, I'm thinking... I think we want to do it like this. Okay, hear me out. I think we want to do it like this when we have all our data and stuff like that. So we add... is this... So I think like the initial thing we want to do is we want to build up this graph. So basically we don't have this graph initially. Unless we take every single point in the full terrain into account, and I don't want to do that. So first I'm thinking of where you can calculate it based on water added and the terrain height. So if a terrain can hold a max amount of 0.5 and the player added 1.5 in the spot. Yeah, exactly. I think Oh yeah, I get you, Fabix. The water cell would have 0.5 if that's maximum. 1 should be distributed elsewhere. Yeah, I don't think we want to work that specific. Yeah, the message limits sucks. But like, I'm thinking... I'm thinking of implementing this initially extremely... possibly in a very bad way. But what I'm thinking is that we build up the graph initially. So we pretty much use the naive approach we have. So we add a cost. We add cost for water to disperse. So basically, if we add 1 here, what I want to do is I want to disperse it in every direction, right? So we disperse it in every direction. Maybe we can just do it like this. 1. So we add here. In the next step, we disperse it in every way. And we don't do it like... The way I want to disperse it is... I want to assign a cost to moving from one grid to another, and it's going to be assigned based on height difference. So it's going to be more costly to move up. It's going to be not all directions if the height allows it to flow. Yeah, but I think you're talking about, like, now we're moving into territory of like more complicated fluid simulations, and that's not what we want. Maybe that's where we will end up. But listen to this, basically. So yeah, and I want to assign a cost by moving up. No. I appreciate every input 100%. I just basically what we're doing here, like we're not trying to do a system for realistically disperse water over a terrain area. We want to develop an algorithm that disperses the water according to our rules, and our rules are fucked up, I know. Like, we want to disperse it in such a way that we create pools of water and rivers between them that goes against realistic fluid simulations. But what I'm thinking here is, I think, like, beautiful tip. I think we're going to use this, but we need to prepare our data and introduce our rules. So if we add water to a point, we add water amount to it, we calculate a new fluid height. We add a fluid amount to it, and then what we do is we move in every direction. We introduce a cost, so it's going to be more costly to move upwards, less costly to move like this, and the least costly to move like this. So then we move from where we added it. We take the amount we have here minus the cost to moving here, and then we add that value here, what we have left. But while we're doing this, we want to build up a graph as well. So we want to introduce this node in sort of a data system, we want to introduce this node, and then we want to add a cost to that node. Yes, I think we want to leave density is gonna... Yeah, I think we can leave density off the table for now. Just amounts. And basically what we do is we disperse this over and over and over. We do it basically like our naive approach. And finally, we're gonna have an area. Oh, not like that. We're not gonna have a half. Finally, we're gonna have an area like something like this, possibly. So these are all... This is how far our water can reach, because we deplete it every time we move a grid. So for each... Yeah, for each node here, we will have a path to its neighbors that also has water, and we will have a cost related to that path. So each of these points will be connected by costs, these costs. And when we have all of these points as well, we can also calculate, or we can get the local minimas, right? So from all of these points, we check, do we have any local minima? If we, for instance, have one here and we have one here, then we know that we can reach an end state here. If we don't have any local minimas within this area, then we don't reach an end state, and we don't disperse water here, basically. You will only get ever-flowing water. When we have the local minimas, what we want to do is, unfortunately we might have something like this. So the next step we want to do is we want to calculate the shortest path, so the least costly path, based on these costs, from this one to this one and to this one. So this will leave us with 3 minimas, 3 paths. Then we will remove the neighboring minimas, and we will do it based on which one has the least amount of water. So we remove this one maybe. So now we only have 2 minimas, non-neighboring minimas. We have the shortest path to those, and when we calculate these paths, we also calculate how much fluid we have in each move. So maybe 0.8, 0.4 and 0.2. What we want to do then, when we have the path and let's see here, maybe we'll have 0.7 here and 7.3, 7.1, I don't know. What I want to do when I have all of this data is that I want to move from this one, or actually I want to take all path steps we have. So this one, this one, this one, this one, this one, this one. We have a total of 6 path steps. I want to sort them based on fluid amount. I don't know what, F. Because what we're going to do then is we're going to loop through all of these, and we're going to take the first one, we're going to fill that one up with fluid amount. Yeah, we're gonna fill up all neighbors to that one with fluid amount if the neighbor doesn't have a smaller height. If it does have a smaller height, we stop. And then we move to the next one, so 0.7. So then we fill up all of its neighbors with 0.7. If it has a smaller height, we stop. And that should give us clean rivers and clean pools of water, I think. It's a fucking mess, but... What's up, Foolbox? It's a fucking mess, but... I think it might work. Like... What it all comes down to, what we want to avoid, is... I want to avoid... Like, our naive approach... our naive approach is good. It's not good, it's acceptable, but it leads to... Is that actually what we had? Yeah, it leads to visuals like this. Yeah, freaking messes are the best messes. I think so as well, Fabic. Appreciate all input. Like, it helps so much to reach a understandable point which might actually do what we want. So if we take a look at this water, where do we have it? What this approach will do, hopefully, is like, now we added water here. We get a local minima here. We actually get a local minima here and a local minima here. We calculate from the input to this minima. And then we walk around. Like, it's this mess on the sides here we're gonna avoid if we just fill it according to the path, I think. Because what we have here is we have water going down, 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 down. That's not how we want it to move. We want the water to stream from one point to a minima, and then we want to fill the water up based on that path, I think. Full box, have you tried look how oxygen not included does it? No, I haven't. But I'm gonna write it down as a reference. Appreciate it. Oxygen not included. So we're going to use... Fuck, I need to learn how to pronounce this great. Dijkstra's algorithm. But we're gonna have different phases. So phase 1 is... Phase 1, find every node affected by water. Phase 2... Or actually, phase 1 is find every node that is affected by water, build a graph from that. Phase 2 is get all minimas within that graph. Phase 3 is use this Dijkstra's algorithm to calculate the shortest path from calculate the we want to get... Okay, it's one more step. When we have all the minimas, we want to get the minima that has the most amount of water. And then from that, we want to calculate... We want to get the minima with the highest amount of height, I think. That's not entirely true. Okay, it's one small hole. But I think we got it. Let's do this. Let's put the pen to the paper. It usually helps. Yeah, like worst case scenario, we can live with this one. We can probably make it look pretty. But let's see here. So what I'm thinking about doing now is some type of this one, but not exactly the same. Iteration 3. I don't know. So I'm gonna write it real quick here. Disperse water based on height difference cost. Build graph from result. Find minimas in graph. Find the cheapest way from question mark to each minima and assign water amount to minima. Find the cheapest way to each minima and create a path for each step. Where each step holds water amount at that step. Take all steps in all paths and sort based on water amount. Fill every neighbor of step with a water amount, actually, and sort based on water surface height. Fill every neighbor of step with that has the same or greater height with water surface height. Something like this. It would look much nicer if you just average out water voxel vertex in y direction, but only on the heights voxels. Oh yeah, definitely. Like I was thinking about doing a filtering on this one as well. But it's gonna take a lot of iterations before it's stable. The positive thing with that, however, is that you can probably do it on the GPU pretty cheap. But like, we could convert this to a mesh as well as it is, and get some nice effect. So the shader is gonna have to do a lot of heavy lifting though. So here you have a pretty still pool, but then you have a flow down to this pool, which is not really still, and you get a heavy flow down here, and you get kind of a curved flow going here. So yeah, like, worst case scenario, we can just take this naive approach and hope that we can implement it, that we can implement a couple of shaders that makes it look pretty. But honestly, this might be it. Although, nah, we have some cases where this won't end well. Or do we? Yeah, it all depends on how all depends on how we define these costs. Appreciate it, Fabic. Like, I'm very impressed by the naive approach. It yields, especially when we introduce the local minima, it yields good results almost all the time, I would say. Can't you calculate them based on local minima depth? Not entirely sure I understand. I wonder how this one would handle. I want to implement this one in such a way that we can get visual feedback on every step. Disperse water based on height difference, custom build graph from the result. Let's just fucking do this. Let's do it. This one is, however, like this is basically our this is basically our naive approach, I would say, but we only add a cost for when we move up. So if we could take the naive approach and build a graph from it, that would be amazing. But I wonder. Yeah, this is basically going to be a naive recursive with an additional step, I think. So I'm wondering if we want to do find closest minima, disperse water at closest minima. So the idea being that if we add water here, we don't want to disperse it from this position. We don't want to disperse it from this position. We want to find the local minima, or the closest minima, which is this one. And so if we put water here, we basically want it to end up here. And it's from this position we want to disperse it based on the amount of water we add. So then we disperse it according to our naive approach. But at the same time we build a graph. Then we find all minimas. Yeah, so it's basically we're going to end up with a result like this. But we have some data here. Minima, minima, and a path between them. And then we fill the water based on that path instead of this. I want it to flow to the initial minima first, I think. Because if we would add water here, like if we take all dispersions into account and we add water here, we're probably going to get these points as well. We want to get rid of those points. But then again, if we add water here, a big amount of water here, one would probably assume that we end up with water both here and here. So yeah. But I think for that use case this one would fix it. So basically if we disperse water here, we disperse it all around. Oops. So we disperse it in every direction, and we might end up with I'm thinking maybe we want to disperse it, but we want to do it in such a way that it doesn't cost anything. Now we need to find You would have to check if the minimas are in different puddles. Yeah, we would, but I think that would be okay with this algorithm either way. It doesn't matter if... Yeah, depends on this one, where we start walking from. That's definitely true. I'm wondering... we're adding complications after complications to this one, but I'm wondering if first we do a spread to find minimas. When we do that spread, we add a cost for moving downward, parallel and upwards. And this is just, we just want to find minimas. So if we add X amount of water here, will it collect somewhere? Like, does it exist a place or multiple places close to here that will collect water, that will fuck is the word I'm looking for? That will collect water basically. So if we add a little bit of water here, we won't find anything. If we add more water, we won't find anything. If we add more water, we will actually find these minimas, and possibly a minima here. Yeah, I'm enjoying the journey. I think it's nice. So then we get 3 initial minimas. And then I wonder if we want to disperse water from those minimas. But when we do it from those minimas, we don't add a cost of moving parallel or downwards. It's great, I'm loving it. Yeah, I won't sue you. Or I won't report you, rather. What they don't know, doesn't hurt them. Yeah, like when we do the initial water, I want to know if we have any points where we collect water, basically. If we do... Okay, so it's basically going to be an initial step to check, do we get to, like, do we have any points which we reach with this amount of water that will actually collect them? So for instance, if we add water to the top of a mountain, we won't find any local minimas. So we will just disperse of it. But then again, yeah, basically what we're doing is just improving the naive one, making it a little bit cleaner. I'm just thinking about how would one differentiate between a local minima here and a local minima here. The naive approach, yeah, if we just take the naive approach without any minima affection, it will flow forever. But what we have now is we have the naive approach, but before we start the naive approach, we find the closest minima and start it from there instead. So the naive approach is good. It never crashes. But yeah. Yeah, but let's see, for instance, so if we have an initial iteration where we find two minimas here, let's say that there's two minimas in here, and we find multiple ones in here. We just want to use one of them as the starting point. You can easily add a check if there's no minima, then disperse the fluid in some max radius. Yeah, definitely. Definitely. One sec, am I making things too complicated? Probably. I would have loved to be able to continue this, even though I'm fucking drained mentally. But I have to run now. But it still feels good. We're getting closer and closer to a good solution for this problem. Yeah, thank you, Fabrik. Appreciate it. I think we're doing good. We're doing good. And unfortunately I won't be able to continue this tomorrow. There has been a slight change, but we will continue it next week. Probably with long streams as well. I'm hopeful. Maybe I can ponder this question a little bit during the weekend and get back fresh on Monday. Yeah, no, Fabik. Great talk indeed, appreciate it. But yeah, it's been a great week, great progress. Yeah, I'm sorry. Skål, Klaus. So yeah, thank you so much for watching, everybody, and have a great weekend. Peace.